let's connect with another simulation. So I have warned you before, the simulation I want to show is this one. I will connect to that very scene. And we will work on it side by side. So what I'm doing now is I'm just closing this file and connecting. I need my IP. Which I have open somewhere. I guess you can't do anything with my IP. So, is it dot? No, it's dot 54. And the only thing I then need is my process. But this is like the standard process, 47827. So I say, okay, connect. Yes, of course. I haven't opened it correctly. So give me a second. Have you experienced in... I'm not saying that out loud because that's the competitor. You know? This is our software. The competitors use different software. You see? Okay. Meanwhile, I just need to close the other simulation and power it up again. In academia, it's mostly the other software. I don't think so. At my universities, at all my universities where I have been, it was Simcenter STAR-CCM+. It depends from country to country, from region to region, and especially from professor to professor. Some prefer this simulation, this software, and some prefer ours. Yeah. The thing is, why professors go for this or that is most likely what they have used as a student themselves. I'm low on disk space. That's crazy. I don't want to be low on disk space. Just give me a second. Helicopter. Okay. When a professor has used one or the other software as a student, it's most likely that they are using this software as a professor again. Yeah, that's just the way it works. Open source software for CFD is a great thing. Yeah. It's great for academia, but it has a high skill cap, so to say. You need a lot of skill to get in this, because the open source CFD software I know is far worse documented than ours. It is far worse supported than ours. Yeah, see, that makes entering this software so much harder. You know what I mean? And for industry, it's another story. Of course, free software or open source software doesn't come with license cost, but only if you have like if you can refer to the standard modules. Yeah, like when you need some special modules, yeah, good luck with that. You got to pay extra. Yeah, open source software is not necessarily free because you might need extra solvers that you don't have in your free code. Yeah. And there's another issue with open source software. You don't have the documentation, the tutorials, and whatsoever. I can show you what it's like at Simcenter STAR-CCM Plus. So like we have this here. This is the user guide. If you printed it, that's like, sorry, you don't see it. Yeah, of course you don't see it. This here, that's the user guide. That's like, if you printed it, that would be 14,000 pages of paper. It's full of tutorials here down here. Say all the tutorials, and that's not all the tutorials. It goes down and down and down. Yeah, it goes on endless. You have a support which doesn't come at extra cost. Yeah, so it depends. Is it cheaper to go open source, or is it cheaper to use a software with greater usability? Yeah, that's either this or that. Okay, let's see. How to break into industry as CFD service providers. Well, there's a lot of companies that offer engineering services. We also do have some engineering service in our company which can support customers, but it's an auxiliary function. Yeah. If you want to break into industry as a CFD service provider, yeah, you can like become an engineering service, and yeah, you need to make build up a customer base, obviously. So let's see if we can connect right now. Is it that process? Let me look on the other screen. Could be. Okay, here we go. We need to go for scene 16, displacement. And now what the virtual reality station is doing right now, it's loading the simulation data or the scene data via network onto the other computer so it can be visualized. That's typical. What? My my headset has just turned off, I guess. No, not my headset, just my controllers. Because I wasn't doing so much for some time. Yeah, as long as STAR-CCM Plus is... Ah, ta-da! Here we go. So, that's the helicopter. It's a little bit sad that I don't have other backgrounds in virtual reality, but we will take it. Okay? So we'll turn on my... Ooh, that's bright. We'll turn on my controllers again now. Yes, and we're going to fly mode. That's very bright. Where's the floor? Ah, the floor is just in the helicopter. That's bad. That's bad. So let's zoom out a little bit so we can move a little bit faster. That's our helicopter right here, right now. And it even has some decent cockpit. And when I did this simulation, I wanted to start the visualization from within. See, that's the older one than the business jet that I've shown previously. And I wanted to start right here with that view and then go outside or something. Yeah, right. So, what I'm showing here is nothing different than the scene that is open on my other computer. I can show you. Let's make it this. See? Here you have the simulation, and on the other side you have me. I'm moving myself out of the picture a little bit. And on the other side, on the other computer, you have here yeah, the simulation. It's just open right now. So let's create some more interesting displayers for it, shall we? Okay, first we want to take a look at our derived parts. Do we have a resampled volume here? Sure, we do. What's my favorite equation? I need to answer Navier-Stokes equations, is it? But I'd say it's some basic Euler equation. Yeah, that's not enough. It's some basic Euler equation. It's e power I phi, and that I pi, that equal plus 1 equals 0. So it has like all fundamental quantities of, I will just type it in the chat. So it's e to the power of I pi plus 1 equals 0. Yeah, you have so many fundamental quantities in there. You have the 0, the neutral element of addition. You have the 1, the neutral element of multiplication. You have I as the complex constant. And you have E and pi, which are both fundamental numbers, both transcendent and irrational, and it all comes down to one equation. So did it copy? No, it didn't copy yet. So we copy this here, resampled volume copy, and then we will yeah, that was a clever answer, wasn't it? Okay, we have everything here. Perfect, perfect. We will make it a bit bigger. We need it longer and wider, I guess. So, the height. Yeah, we need it higher. So this gonna be 8 meters. The width is gonna be something like 12 meters. Ah, it's not even enough. How big is that rotor? So 20 meters? That's decent. It's too much. That's too much. Top. Now 20 meters is fine. And yeah, 8 meters from the side is fine. And let's make it something 40 meters. That's fine. So now we're dragging that over here. Okay. First, we want to make something to create bubbles. So we are making a vector display here. And the funny thing is, on your screen, the vector displayer doesn't even work. Yeah? You don't see anything. Apart from seeing my computer working decently on this simulation, obviously. It's just putting a resampled volume into the vector displayer has no effect on the screen. But it will have some effect in the VR once my computer decides to react. So, as we can see, no matter the hardware, it gets to a limit. But I'm not sure if we are at any limit here. Oh, come on, computer. Do your job. I don't know what's wrong today with this simulation. Maybe I should have created this before. But I thought it would be good to create it live. Just give me a second. I have some bad feeling. Maybe I have just opened up the simulation on a single core. Yeah, I can't change this. We need to work on this like that. Yeah, that happens if you're doing simulations live. Sometimes it's not properly working. Like here. I am so close to kill my Simcenter STAR-CCM Plus. Okay, never mind. Okay, if the helicopter doesn't work, we will just go on with another simulation, shall we? Kill it with... Yeah, now it works. Ah, it might have something to do with the connection to the virtual reality. Yeah, see, we just disconnected here. Okay, So we have that one here, which is here our vector scene, which we don't actually see. We call it VR vector. Yeah, vector with a single O. So we have parts in here. Yeah, the resampled volume. We have a velocity there and a color bar. Yeah, whatever. Take this one for velocity. I think that's suitable. We'll put it over here. And first thing I do when working on these, I will... you don't see it. Sorry. I will put it up here so we can all see it. The lower limit is obviously 0 and the upper limit will be 480 kilometers per hour. See, and that way the legend at least looks like something. But this one is the advanced, the for the logarithmic scale. Yeah, let's keep them anyway. Maybe it works, maybe it doesn't. And let's connect to this. So what we're gonna do is we say connect here and we say okay, because it remembers where we took off, and we are connecting the virtual reality stuff to here. So obviously for bigger changes we need to, come on, we need to, where is number 16, displacement, we need to disconnect. It's better, but it still works if you have this connection. Actually, this simulation was also not done by myself. Yeah, I need to stress this. This simulation was done by a very skilled engineer in our department. He really worked on this, and actually the feature which is shown here, it's rotor blade aeroelasticity. Sorry. And rotor blade aeroelasticity is done in co-simulation. It really, the blade depends really strongly on the mechanical position and the fluids around. See, if the structure just changes by a degree, that totally means something different for lift over the profile, right? And thus it's really important to have that fluid structure interaction. This feature was actually the result of a PhD thesis by a famous colleague of mine, and if you go for Simcenter rotor blade aeroelasticity, you should find this blog. I reject cookies, and that's my outcome. That's our outcome from that time. So here we have our experts, and it was her PhD, by the way. It's a cool story. There's so much about helicopters to learn in here. I can only really say take the time and read through it and learn a little bit about the feature. It's cool. So, ladies and gentlemen, how far are we with our VR stuff? Are we finally connecting? So we are establishing a new VR client here, obviously. Maybe the resampled volume is a bit too big. I haven't checked, to be honest. It might be a little bit too big. That's why we are seeing these issues here. Let's check how much more to download. No, it's just, yeah, we're connecting via gigabit, and that doesn't seem enough at that point. Yeah, it is some data if you have these big resampled volumes. Maybe I did it a bit too good at that point. I'm thinking about canceling the... Yeah, I have some error message in the background on my VR station, I think. No, I don't. Yeah, let's give it a minute or so. Are we done transferring data? Not yet. Okay, that was a little bit too ambitious, I suppose. End task. End task. Okay. At least we got our functionality back. So we need to check the resampled volume here. We go for edit part in current scene, and we can check how many voxels there will be. 160 million damn voxels. Okay. 7 million voxel. That sounds more like it. And I was wondering why that didn't work. Okay. Yeah, if you randomly change some numbers and then suddenly it doesn't work anymore, yeah, don't wonder. Okay, let's try to connect again. We are going for the scene 16 displacement. We got another client, yay! And VR is VR loading. I can already turn on the display again. Okay. Should take a minute or so. And we're done! Yes, finally! So, let's make this one big here. And let's get into it. Where are my controllers? Here and there. Okay. Yes. So fly mode was activated. Actually, you can see I activated fly mode last time, and it was saved with the simulation actually. So here we go. We have bubbles. We have bubbles. We are creating bubbles. We can make them faster. We can make them faster. That's not too interesting, is it? I thought it would be more interesting. Ooh, we have found some drag. The jets are also working, I suppose. Yay, they're faster. Holy moly, what's going on there? That's interesting. So I guess our upper limit... Oh yes, it was 400 meters per second. That's like idiotically fast for a helicopter. Okay. So, I've set up this for here for now. Yeah? I'm just gonna leave it as it is and work on the scene on the computer while VR is still working. Okay? So, putting my VR scene here, having my other scene there, maybe putting it here right in the middle behind me. Look a bit to the left, please, and down. Okay, like that. Okay, I think that color bar is out of range, so let's make it down. What do we think is 150 meters per second suitable? Yeah, maybe. An instant change in colors on these bubbles. It's even faster than I supposed it might happen. And it's not even enough, so let's go for 120 maybe. And the lowest color maybe for 20. So we have, yeah, maybe. That sounds reasonable to me. Or maybe go a little bit up here. Yeah, we see some color change now. And make this one 50. So we have an interesting area where we see changes, right? See, from the engine, the bubbles are now coming out at... I will dive into it to show. And why should I explain it outside? Okay, so here from the exhaust, they are like yellowish to white, right? We have the full color band. See that color band, and dark violet is on the surface here. Whoa, whoa, whoa! Where was it? That's nice. That's nice. It's just slipping over the edge. It's just slipping over the edge. That's cool. But I guess the displacement is like morphed, so it's shown bigger as it is in reality. The thing is, I suppose our lighting is a bit too much in the virtual reality. So let's turn them off and this one back to 1. And it's dark. Yep, that's better. Now my controllers are not that bright as well. Yes, nice. Okay, cool. Looks reasonable to me. Okay, let's add some more visualizations to this. Okay, shall we? So, we have that helicopter. That's like the toughest part. Positioning it correctly without having the goggles on. So, let's go. Maybe we turn a second light on here. Yeah, that's better. Okay. So we have that resampled volume displayer as for our bubbles, but I also want to add a second displayer for another quantity, which is Vorticity. Let's check. There is another scene where my dear colleague has shown the vortices. Just opening up this scene. Whoops, sorry. Putting these aside a little bit for now. And I want basically just to copy these vorticities. Okay, let's just disconnect for a sec. No, not connect. Let's just disconnect for a second here. Maybe that makes things faster at our end. Yes. So this is something we must still work on. And this is the famous scene that everybody has seen before, probably. And I want to take these surfaces, and it's L2 isosurface. Okay. So it's lambda. Scalar field L2, lambda 2, I guess. No, I'm not using this. We are using something different. So let's go to this one here and say we take the resampled volume copy and make a new scalar here. So let's select a function. So the function will be vorticity. Yeah, let's go with vorticity magnitude, shall we? Okay, worked. So we need to go back in there and tweak it a bit. So this is VR Vorticity scalar. And yes, the scalar field, yeah, this needs to go here. And I guess we go with 1E4 for now. And the color bar will be hey, let's just build a new color bar, shouldn't we? So we take the basic Siemens color bar and make it 512, and then we go to our power toys, and there is that functionality saying color picker, which is Windows, Shift, and C. So we take Windows, Shift, C, and this color will go into our color bar. So we say edit a copy. Siemens Sky, I will call it. And this one, so we take white for the middle, maybe. And here we just paste our RGB code. This one needs to go. And this one needs to change. So we need some blue from here, probably. Windows Shift C. That's a dark blue. We say here, come on, paste it here. We need something brighter. Can we have something brighter here? There's no bright blue here, I guess. So let's go with this, and say okay. We go with another color. This one was our first one. Okay. And we just change it a little bit. And making it brighter. Just like that. Okay. And we need some color from here. Windows C. That's brown, actually. So this one will replace our white. Here we go. I guess this nicely fits into our background. Now we need something dark down here, which will be the color up there. Okay. Let's stick with RGB for now. This one needs to be brighter because it doesn't fit into here. Now it does. Let's say okay. The thing is, it looks totally stupid on that end, but when we connect to it, it might look better. Not guaranteeing at that point. I need to select my scene, which is called 16 displacement. And then we're gonna load. And there's a new VR client coming up. Okay. Hey boss, if you're in the chat, if you're watching me, you can also start chatting, right? By the way, I switched my background removal tool. Do you still think I need a green screen? So let's see. Hasn't yet loaded fully. The funny thing is we will... No need for a green screen. That's good. It's actually an NVIDIA feature. I found out that you can use your graphics card to AI-ly remove your background. And actually I'm following other streamers who stream about how to stream, and they did a great job in explaining me how I can use the tools that I have at my hand. Because I'm not only a potato when it comes to meshing, I'm also a potato when it comes to things with Twitch and OBS and whatsoever. So can we have the scene please here? That's like the worst of CFD, waiting for stuff. But at that point I guess it's not CFD, it's just my my local connection between devices. Oh, come on. Hey! Here we are. Okay, it's a black cube. Why the hell am I seeing this? I thought this was not the way it's meant to be. But let's find out. Did I change left and right here? Hey, here we go. Sorry. Something is wrong with that scene. I'm sorry. And I don't know what. It doesn't even move anymore, does it? I guess my headset is tired. Okay. That didn't work. I don't think I have done anything particularly wrong at that point. Let's give it one more try. And if it doesn't work, we will just call it a day. I learned something today. I need to check before I present. But I guess that's what we are here for. That's why I'm streaming in the game development department section of Twitch. Software and game development. Okay. So it seems like we already have that connection here. And I hope that sooner or later it will also show some CFD on that scene. So, cheers. Uh-huh. Okay. Yeah. Better. I don't know. I haven't changed a single thing. I just connected and disconnected. Yeah. And my headset has crashed. Oh no, ladies and gentlemen, what is wrong? What has crashed? Oh, the whole headset has crashed. Let's give it one last try. Nope. Yes! My headset is sleeping. Wake me up. So let's shut this down. That's the bad part. This headset needs a certain order to go up and go down. Yeah. Okay, ladies and gentlemen, I guess that's it for today. My headset is sleeping, headset tired, headset sleeping. That is beyond repair apart from restart. So that's why I will call it a day at that point. Thank you for your attention. Yeah, KLX 2018. Thank you for your participation in the stream chat. And thank you for that interesting question asking me for my favorite equation. Yeah. Thank you for all these first chats, and thank you for all these people coming back to my stream. I will continue tomorrow, and then the headset will be no longer sleeping, I suppose. Yeah, thank you, and goodbye. See you next time.